Okay, this is a continuation of the first lecture. And now we are starting some applications of Kirchhoff's law. Now, in order to apply the Kirchhoff's law, whenever you have a circuit, there are three steps that you have to take into account. So the first step, identify the junctions in the circuit. Because the junctions, this is where you will apply the first rule of Kirchhoff, or the first law of Kirchhoff. The second, if the direction of current are not, the direction of current are not given, then choose randomly direction of current. So choose directions if the directions are not given. So the third is define your loops. Define the loops. Because again, the loops will help you apply the second rule of the second law of Kirchhoff's. So let's start by applying those three steps. And of course, once you define the loop, then you can write the equations according to the Kirchhoff's law. So let's start. The first thing is we have this circuit. So we have three batteries here, 12 volt, 7 volt, 13 volt, and we have three resistors. And we would like to calculate the current into each branch. Now, I will start by identifying the junction. I know that this is a junction. This is a junction. And this is a junction, okay? So those are the junctions. What is in blue or what are in blue is the junction. And then I want to start identifying or choosing direction of current. So for me, I will choose this one as I1, and this current here as I2, and this current as I3, okay? And then I will also define my loops. Let's define the two loops. We can define the three loops, but let's define loop number 1 and loop number 2. Now we can also define loop number 3, which is the loop here. Okay. But I'm not going to use it for the moment. So now let's start writing the equation that is associated with the junction. We know that the junction rule tells us, due to the conservation of electric charge, the sum of the current going into the junction is equal to the sum of the current going out of the junction. So we can easily see that the first rule will be I1 is equal to I2 plus I3. This I will call rule number 1. Then let's go to the loop. Equation of loop number 1. Remember, what we have seen is when the loop is going into from negative to positive in the battery, it will be positive. And if it is going into the same direction of the current across a resistor, it will be a negative. So let's apply this. So loop number 1, it is going this way. Okay, so it is going this way. So this means here across the 12 volt, it will be plus 12. So plus 12. And then when it goes to this, it is going in the same direction of the current. So it will be minus 5 I1. Okay. And then for I2 here, it will be minus 5 I2 because it's also going in across the resistor. The resistor is going the same direction as the current. And when it goes to 7 volt, it is also minus because it goes from positive to negative. So it's minus 7 volt. And then we go back to our initial point, which is 0. This I will call equation 2. And then I will go to loop number 2. Again, loop number 2, if I start, for example, from from any point. I can start from here and then go this way. It will give me minus 5i3 plus 13 volt, okay, plus 7 volt and plus 5i2, because the loop number 2 is going into the opposite direction of current i2, which means the potential difference across the resistor will be 0. So it is 0, and then I have 3 loops. So here I have three equations, so a system of 3 equations that contains 3 unknowns, I1, I2, I3. So it's a very easy system that we can do either through a determinant, we can solve either through a determinant or through substitution. Let's do a substitution. Let's take equation 1 and plug it into 2. So, for example, yeah, so what we can do, so 12 volt minus 5 times I2 plus I3. So here, what I did, I replace I1 by its value, okay? Minus 5 I2 minus 7 volt, so it will give me 5 volt, okay? 12 minus 7, it will give me 5 volt. So 5 volt minus 5 I2 plus I3 minus 5 I2 is equal to 0. I can develop a little bit. So it's 5 minus 5 I2 minus 5 I3 minus 5 I2 is equal to 0. So it is 5 minus 10 I2 minus 5 I3 is equal to 0. And this will give me easily an equation that is equal to I2 is equal to 1/2 minus I3 over 2. So this I will call equation number 4. And then I will plug equation number 4 in equation number 3, which is the one that corresponds to loop number 2. So this will give me minus 5 I3. Here, 13 plus 7 will give me 20 volt plus 5. Now, I2, I will replace it by 4. So it's 1/2 minus I3 over 2. So this is I2 from equation 4. Okay. So now I can isolate for I3. So I can isolate for I3. So it will give me 20 plus 5/2 minus 5 I3 minus 5/2 I3 is equal to 0. And this you can easily see if you isolate I3, you can easily see that I3 will be equal to 3 amps. Okay, I3 will be equal to 3 amps. So you just do the sum of this and the sum of this and then apply, and then you can easily see. Now, we have also from equation 4 that I2 is equal to 1/2 minus I3 over 2. So this gives you I2 is equal to minus 1 ampere. And you can also use the first equation that we developed, I1 is equal to I2 plus I3, and it gives you 2 amps. Let's go back to our original circuit. So I1 has 2 amps, okay? So let's go to our original circuit. So I1 is equal to 2 amps. I2 is equal to minus 1. So this means that I1, in reality, I2 is going this way. So this is the real I2. This is 1 amp, and I2 is equal to 1 amp because it's going in this other direction. And then I3 is equal to 3 amps. So this is just a a simple application of the Kirchhoff's laws. Thank you very much for your attention.